In this set of problems, we are going to use this relationship. 1 mole of a substance, atoms or molecules, is equal to Avogadro's number, 6.022 times 10 to the 23rd atoms or molecules. We're going to learn to do some problems using this relationship. Let's look at the first example. How many moles of uranium are there in 3.64 times 10 to the 19th atoms of uranium? So we are given 3.64 times 10 to the 19th atoms of uranium. And we are asked to figure out how many moles of uranium do we have. Okay, I have written this relationship up here, and I'm going to keep that up for all of the problems that we're going to work. This is my relationship. This is my conversion factor. 1 mole has 6.022 times 10 to the 23rd atoms. What about this many atoms? How many moles is that? Let's start with what we're given. 3.64 times 10 to the 19th atoms of uranium. And now I can write my conversion factor multiplied. I want moles on top because that's what I'm looking for. 1 mole of uranium contains 6.022 times 10 to the 23rd atoms of uranium. My atoms will cancel, and I have 6.04 times 10 to the minus 5th moles of uranium. Note that I use 3 significant digits because that's the number that I'm given. These do not count toward significant digits because these are considered as exact numbers. So this is my answer. Now let's kind of double check and make sure that we've done it right. We know that 1 mole contains this many atoms, but I have much fewer atoms than those, which means that I will have fewer moles than one mole, and I do. I have 6.04 times 10 to the minus 5th moles. Let's take a look at the next example. How many molecules of sodium chloride are there in 0.54 moles? I have 0.54 moles of sodium chloride. Once again, I can use this relationship. I know that 1 mole of sodium chloride contains 6.022 times 10 to the 23rd molecules of sodium chloride. Therefore, I can use that as my conversion factor. Now, because I'm looking for molecules of NaCl, I want that on top. So I have 6.022 times 10 to the 23rd molecules of NaCl on top over 1 mole of NaCl. This will cancel, and it will give me 3.3 times 10 to the 23rd molecules of NaCl. Now let's think about the answer. I have a little over half a mole of NaCl, and 1 mole I know has 6.022 times 10 to the 23rd. So about half of that will be 3 point something, and that's what I get, 3.3 times 10 to the 23rd. Therefore, I have done this problem correctly. I will erase these 2 problems, and we will work on the last 2, which are a little bit more involved.